Okay, hello everyone, and welcome back. Y'all, today we're going to look at the fundamental counting principle. And we've been looking at probabilities, and now we're going to look at different ways to count number of events and number of outcomes. And, the objective for today was to learn a simple method to count the number of possibilities for an event happening. The essential question: how do we count outcomes and events which are difficult to count? And we're going to do this for 4 days, different counting methods. All right, and then Friday we're going to tie it together back with probability. But just to review, guys, remember probability is a ratio, it's a fraction of two numbers. It's all the events we are measuring over all possible outcomes. And sometimes it's hard to count how many events there are and how many outcomes there are. So we have different techniques to learn how to count things. The one we're going to talk about today is the fundamental counting principle. It's stated here, again, if there's two independent events, right, if there's m ways that one event can happen, and n ways another event can happen, then there's m times n ways they can both happen. And we talked about this before a little bit with probability, but now, again, we're just counting how many ways. We're not measuring probability yet. Just the number of ways that something can happen. As an example, here's the bread, the meat, and the cheese, right? All right. 5 different kinds of bread, 8 different kinds of meat, and 6 different kinds of cheese. How many different kinds of sandwiches can I make with all those different combinations? 240. All right. I remember dice, 2 dice, 6 ways you can roll one dice and 6 ways the other dice. That means there's 36 total possibilities when you roll 2 dice. Again, another example, if you have 3 shirts and 4 pairs of pants, you can mix and match. 3 times 4, you can have 12 different outfits. Or if there's 6 different flavors of ice cream, again, another example, 6 flavors of ice cream and 3 different cones. That means you can have 18 different single scoop ice cream cones. All right, 6 times 3. Another example, you're buying a car. Again, you want 2 different body styles, 5 different colors available, and 3 different models. All right, a standard, a sports, and a luxury model. Again, those are 3 different choices, and you can do it that way too. Just multiply those 3 numbers together. All right, you can use a tree diagram too if you like. Again, 2 times 5 times 3. That's 30 different possibilities, 30 different ways that the car you order, you can get 30 different cars. Now, sometimes they're dependent, though. Events aren't always independent. Sometimes they're dependent. All right, so just a simple multiplication, it's not always right. And as an example with the cars, if the salesman says you can't choose black for the hatchback, we don't make the hatchback in black. Well, then you don't have 30 possibilities anymore. You lose 3 different possibilities. You see them right here. These 3 right here are gone. All right, you can't get black with the hatchback. All right, so it's not a simple multiplication. You take these right here, that's 5 times 3, plus the 4 times 3 right here. That's how you get the 27. Again, you've lost 3. Again, another very important example. How many different ways can you arrange 4 trophies on a shelf? Well, you can put them in different orders, like a lineup. It's simply 4 times 3 times 2 times 1. Again, in the first slot, you can put 4 different trophies. But once you put one in there, the second slot, there's only 3 trophies left you can put in there. And in the third slot, now there's only 2 left because you've already put 2 in the first 2 slots. And the last slot is always just filled with the one that's left. In another example, these are dependent events. How many different ways can you order 3 digits and 3 letters? All right, for a license plate, when no digit or letter can be repeated. Again, so that makes them dependent. They cannot be repeated. Again, there are 10 digits, guys, 0 through 9. So the first position, there can be 10. The second position, there can be 9. And the third position, there can be 8. That's the first 3 numbers right here. There could be 10 in this first slot, but then now we've used one and we can't repeat it. So we use 9 in the second slot. And now we can't repeat either one of those, so the third slot, there's only 8 left. But then you multiply that times the letters. The first slot, there's 26 letters you can put in there. There's 26 letters in the alphabet. But once you put one in there, the second slot, there's only 25 letters left. And the third slot is 24. So you end up with over 11 million different possibilities for the license plate. And another example, again, these are dependent events. 8 runners are running in a race. How many different ways can they finish first, second, and third? Again, once one runner finishes first, they can't finish second. All right, we're not talking about any ties. There are no ties. Someone finishes first, and then second, and then third. Again, y'all, 8 runners can finish first. But then there's only 7 left to finish second. And then there's only 6 left that can finish third. There's 336 different possible ways that can happen with 8 runners in a race. All right, y'all, that's it. Next, please complete the homework assignment. At least just take a look at it. I know we're going to look it over in class. All right, that's it. Thank you.